Okay, you are welcome in today's tutorial, Mr. Great Tech Review and Mr. Great Tech Review Studio. And in today's tutorial, we are going to discuss and we are going to say today, all we are going to do today is analog write command. And this tutorial is a continuation from tutorial 1 to tutorial. Today's tutorial should be tutorial 13, analog write command. Okay, we have done digital write stuff, analog. We are going to do analog write now. And in analog write, it's not gonna be zeros and 5 volts. Okay, let's say zeros and 1. It should be in between 0 and 1, something like 0.5, and that is it. And in analog, all about analog write command. At the end of the program, you understand why you have to learn the analog write command, why analog write command is important, why we are doing analog write command, not only zeros and 1, high or low, in between voltages, and we are going to see. And also that is when you understand the float variables and rest of them as we go on. And you have to understand the pulse width modulation. And so in analog write command, you normally use the pulse width modulation port, the pulse width modulation pin. So when you look at the structure of your Arduino board, you see the pin that is something like sinusoidal wave, squiggling sign. That is the pulse width modulation pin, and that is the pin, that is the only pin that you are going to use to give out analog command. So that is it. And to read analog command, to read, you use the A0 to A5. That is the analog in. That is the analog in for you to read. Then for you to write, to give out analog write, to give out command, you give out from the pin with squiggling sign, with the pulse width modulation sign. Okay, so that is it. So that is how the analog write command works. So I'll have to play something here. When I play it, you have to understand what is going on here. Is a voltage in between. It is not all that 0. And we have you have 5, and in between 5 we have a voltage in between, so it changes the sound of the buzzer, and you see the LED dims. So I use analog command to program it. So at the end of the day, this is just what we are going to achieve today. So you can see, when you look at LED very well, you can see it didn't go off completely. So at that point, the voltage is not all that 5 volts again. So you can see it didn't go off completely. When it is off completely, it will be 0 volts. But you can see now there's a delay in between the high and the middle voltage. Understand? So that is it. So that is what we are going to achieve today in our analog write command. So let's go and see the program, how we can be able to achieve that. Just like I told you, in the Arduino you have these ports. You can see the ports. So the port with the squiggling. So let me come close so that you can be able to view it. So you can see it. So you have the pin number 3, number 5, and the number 6, number 10, number 11 has the sine wave sign, sinusoidal wave sign. So these pins are used to achieve analog write command. So I'm trying so that my camera can capture it, but it's an autofocus, so I find it difficult to picture it. Maybe I'll set it on manual focus so that times like this it will just capture very fast. So these pins are used for, I will use it for the analog write command. Okay, so in analog write command there is something we did on we did during our lectures on binary counter, 4-bit binary counter, 4-digit binary counter. We did something like this. You can remember, and we did something like this. The binary number, we did something like this. So I told you that it goes, if you check the sequence at which this number flows, you have the 1, 2, 8, 1, 2, 4, and 8. You can visit that tutorial. You see the sequence at which this number goes at the binary. So now let me come very close so that you can be able to see what I'm talking about. Okay, so you see the sequence at which these numbers go. You see, you can remember vividly when we work these things out. It is 1, 2, 3, 1, 2, 4, 8. So multiply that. That should be 2 raised to power 8. That is the sequence. That is when you count the zeros, the number of zeros here. You see that it's a sequence of 8, then you have 1. It's a sequence of 4, then you have 1, 4. There's a sequence of 2, then you have 2, 1. There's a sequence of 1, 0, 1, 0, 1, 0, 1, 0. So that is 1. So you look at it, it should be, so when you want to do analog write, in analog write command, you have, let me remove this so that to stop making noise. It's okay. So okay, that is it. So in analog write command, just like I told you before, in analog write command, you have 0, which is 0 volts. Then you have 5 volts. You have 5 volts. So Arduino gives either 0 or 5 volts. Okay, let's say you get 0 or 5 volts. Have 0 volts or 5 volts. So in analog write command, the 5 volts is equal to 255. 255. So that is the scale of resolution in Arduino. You don't just in analog you say, okay, since you have 0 volts, then you have 5 volts. Okay, so you're supposed to be 0, you have 5 volts. No, that is not how Arduino is being programmed. It is programmed by 255 values. That, just like I told you in the binary, where you have your one, where you have your, okay, let's say 1, 2, 4, 8, you have 16, you have 32, you have 64. Just how this number is being how they got this number. You have 128, you have 256. So when you start from 0, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is how they got this number 255. So now 255 is a 256. So 255. So it should be 2 raised to power of 8. So I just want to break it down. So yeah, it's around 8 bits of resolution. So 8 bits of resolution. That is how this number. I'm trying to tell you how they arrive at this 255. 8 bits of resolution. So that is it. Now is how we got this 255. So in a scale of 255, you have what? You have 5 volts, which is the highest 255, and between, it's not all that exactly like that, but between the 0 and 255, you have the voltages between 0 and 5 volts. So that is just it. Between the 0 and 255, you have the voltages between 0 and 2. So you have half of 255. 125, we must give you about 2.5 volts. So that is how we got to this point of of resolution, of 8-bit of resolution. So that is it. So now we are going to make use of this number. Is you are not going to put 2.5 volts or 3.5 volts. Either you write 0 or you write numbers within the range of 20 to 255. So that is how we are going to do it now. Okay, so let's go back and see. So now let's go back and see on our program on how we can program with an analog write command. Okay, now you can see on the left hand side of your system, on the right hand side of your system, I have my command. I did it, so I will delete it again, then we'll write it, we'll do it together, we'll write the program together. So it's very simple. Now you can see on this place you have int. Like I told you, you use your variables. Int red pin is equals to 9. We can use any number that has a squiggling sign. You have 9, you have 10, you have 11, you have 6, you have 5, you have 3. Any number with a squiggling sign, that is the sine wave sign, is the number we are going to use. These are the pulse width modulation pins, and we are going to use it for analog write commands. So these pins are the pins we are going to use for our today's tutorial and all subsequent tutorial. And anytime you are doing analog write command stuffs, you use these numbers. Anytime you are doing something that has to do with pulse width modulation, either 0, if it's not 0, it's not 1. If it's not 0, if it's not 5 volts, you use these pins. In between voltages, you use these pins to do it, to write your programs and to simulate your programs. Okay, so that is it. So now you can see okay. Now let me open another file. Examples, basic, bare minimum. Sorry. File, examples, bare minimum. Okay, let me just write the program myself, and let's see. So I have int red pin, red, pin, sorry. Okay, well, we use a white LED, we can use red pin, green pin. Okay, let me just, because we can still change it, let's use red pin. Red pin is equals to 9. Enter, int again, bright pin, bright, which is our GHT, bright is equals to 255. Okay, pin mode, our pin mode, red pin, outputs. semicolon. Okay, this place analog write instead of digital write we have been doing before. Analog write in brackets red pin. Red pin, comma, bright, PHT. Okay, bright. Okay, see semicolon. Okay, so we can now download this and see. Let's download it and see. So let's check 255. It's still showing me analog write red pin. Okay, glory. Okay. Wow. I didn't put close glory at the end. Okay. Okay. Okay, let's go. Okay, good. So that is it. So actually what actually happened here is that I copied the wrong information from my wrong examples to the new bare minimum, and it refused to accept the command. So once the command is wrong and I didn't write it on bare minimum, so whatever I copied from that place to bare minimum is not going to work. So that is it. So the more you program, the more you know how this Arduino environment IDE works. So you can see now it's steady, and when you check our program on the system, you see the program in the system. You see it now. So this is the right program. Okay, this is the right program here, and this is the wrong program. I didn't write this on the IDE and the bare minimum, so I used bare minimum to write this one. I didn't use bare minimum to write this one. So I'm going to shut down this one. I'm going to set this to, you can see now. Okay, which one is this one again? Okay, let me shut it down so that I don't confuse ourselves. Okay, now this is it now. So now I have, you can see now it's steady and bright. It's just like digital write. So but now we are going to reduce the voltage. This is just 5 volts out, so now we are going to bring down the voltage to half of it. Maybe let's put 125, which is 2.5 volts. So easily you come to this place 125, then you upload it and see. You see the buzzer will change sound. The buzzer has changed and it's not getting more voltage again. It's not getting up to 5 volts again. You can see, and the brightness of the LED has reduced. The brightness of the LED has reduced. You might not notice the brightness, but maybe I can do 25 or 12. Let's do 12 and see. Let's do 12 and see, so that you can actually see that the brightness of the LED has actually reduced. As you can see, it has reduced. So the brightness and the sounding of the buzzer also has reduced. So that is it. So now let's go back to 255, and let's upload again and see. Okay, you can see now. So now that is it. It's very simple to using it is very simple using your variables when programming, so that you can be easily correct on your program. If you want to adjust, if you want to edit your program, you can easily edit your program. Okay, now it's a very simple thing. What we are going to do now is to just add a delay in between the voltages. So let's do in between voltages at 1 minute, at 1 second. It will give us maybe 255, and the other side in another 1 second is going to give us a 25. Okay, so it's going to give us different voltages at the same, with different delay intervals. So that is what we are going to do now. So let's do it in such a way that you have different delay, two delay with different voltage intervals. So you have something like, you have 1.5 volts, you have 2.5, you have 5 volts, or you have 5 volts, or you have 2.5 volts, then you have a 1.3 volts with a delay of 1 second, which is 1000 milliseconds. So let's do, that is what I did here in this this actually what I did here. So now we are also, okay, let's change pin and use pin. Let's change pin and use what pin are we going to? Okay, let me use 3 because I want to use 3. I like using 3. Okay, now let's upload and see. And this, okay, so nothing is happening. Why? Okay, because I have to change my red plug, my red jumper, to pin 3. So let's go to pin 3. This is 0, 1, 2, 3. Okay, I have it in 3. Okay, so that is it. So now, okay, let's now add some more features to this program, to this analog write program. Just like I said, let's add some more features to it. Okay, let me do in such a way that it will not be bright again. Let me use high and low. Remember, let me use high. Okay, no, if you do it this way, you are telling Arduino, you are giving Arduino another command in your variables. Okay, so now that's why I use HI. Something like this is a wrong command to Arduino, so use HI. Okay, now let's use int. Oh, sorry, you can see it didn't turn, so it's showing that you're wrong. Int, you have low. Okay, is equals to what? Maybe let's do equals to 30. It's equals to 30. Okay, put semicolon. Okay, so now let's add a delay. Int long D, or wait time. Int, okay, sorry, int long D. It's a long delay, long. Okay, long D. Okay, is equals to what? Let's put 2000. Long D is equals to 2000. So that is it. That's our delay. Then our pin mode is what? Red pin is output pin. Okay, now analog write. Red pin is equals to what? High. Sorry, use the same. Okay, high. Okay, now we add a delay. Okay, then you put a delay. Put a delay. A delay. Delay. So our first delay is what? Our long delay, sorry, I have put our delay as what? As long D. Long D. Long D is our delay. Bracket closes, semicolon. Okay, now we copy this and paste. So Ctrl C. Ctrl V. Okay, now so we are going to long D. Sorry, analog write. Red pin is high. Sorry, is high, and we have a delay, a 2 seconds, the 2 seconds delay. Then red pin is what? Low, LO. Okay, so that is it. Now let's play this and see how it goes. And I think all things being equal, ceteris paribus, we are good to go. Let's upload and see. Okay, something is wrong here. We didn't put a semicolon, so put semicolon. What place again? Made a mistake. Okay, let's go again. Low was not declared. Okay, see where we made another mistake here. Low was not declared, so we put low like this. Okay, so let's put LO, capital letter LO. Low was not declared. Okay, so capital letter LO. So now low was now declared. Now let's go again and see. Good. So okay, you can see. So this is it now. You can see now, as you can see, you have in between voltages, you have the high, you have the low. So something like pulse width modulation. Okay, until we get to pulse width modulation tutorial, I will leave it at this point. I will leave this tutorial at this point. So this is actually analog write command. How we can be able to use our analog write command to achieve this. So you have different voltages, Let me remove the buzzer so that you will see how the light is flashing, just like a flashing light, so that the buzzer is making a kind of noise. Can see? Can see it? So I just want you to use the buzzer so that I can be able to clarify myself, and that's why I'm putting the buzzer, so that to put more spice to the tutorial. Okay, so now we can now alter the the delay value, I mean the high and low values, you can go for, here we have let's say, let's use 100 here on the low side. Let's see. Okay, so you have 100. Okay, now let's use 100 as, let's see what happens. 100. Okay, something happened here. Okay, because I used 100, the delay was not visible again. Okay, so because immediately it finishes, it goes to 100 again. So let's use 12500. 12500. Okay, let's use 12550. Okay, 12550. Okay, 12550. 50. Okay, let's apply 0. 125 0. Okay, 125. What did I put there? No. Sorry. 125 0. Okay. You see, this is just like digital right. It's just like digital right. So that is it. So this is the end of the drill. This is where we are calling it a day on this tutorial. And in our next tutorial, we are going to do what in the next tutorial? Okay, so you leave that one for me to decide where we are going on our next tutorial. So on tutorial 13, I will come up with other amazing programming stuff so that we can move this tutorial forward. So thank you very much and God bless you. Remember, get yourself this. Very important, this training kit. It is what we are going to use to finish our Arduino course from A to Z of this program. This is what we are going to make use of. So do yourself a favor by getting this, the most complete starter kit for Arduino. So it's going to help you. You're not doing it for me, you're doing it for yourself. So thank you very much and God bless you. And your one and only Mr. Great here in Mr. Great Tech Review Studio. bringing technology to your doorstep. If this video makes sense to you, please like and share so that others will benefit. And also join me on my YouTube channel so that we can be able to also, that is where I have the opportunity to post long-lasting videos on my YouTube channel. So subscribe on my YouTube channel and join me. So let's explore the world of tech. Thank you very much and God bless you. Once again, I'm your one and only Mr. Great at Mr. Great Tech Review Studio. Thank you. Okay.